Hi guys, we continue with solving our Leetcode, so let's check our next task. Our next task called balance a binary search tree. So we're given a root of binary search tree. We have to return a balanced binary search tree with the same node values. If there is more than one answer, return any of them. A binary search tree is balanced if the depth of the two subtrees of every node never differs from more than one. So, for example, we have such tree and we want to balance it. So in this case, we see that balance a tree if there is more than one answer. Okay. If the depth of the two subtrees of every node, so we have this node 1 in depth 1 and here depth 2, never differs by more than 1. So here it's difference 1, so it's correct. Here, again, we have like two nodes, and they should, like, it doesn't matter whether they, it's not binary, it's just balance, right? So we should just balance it. So here we can take whether 2 or 3 as our root node. It's already balanced as well. So let's think. So first about clarification. So we have some tree. Yeah, it can be different one, but yeah, let's consider this one or even this one. So what we can do, we can find the median value of this tree, and this would be our root. Then for each of subtree here and here, we should also find medium here and build subtree, and also find medium here, here, and build some tree. So our problem looks like a divide and conquer problem, where we like middle of a subtree and build tree. When we have tree like this, yeah, so we have tree like this, and we also see it has a root node, right? So for example, 3 here. So we should return 4, 5. That would be our right. And 1, 2. It will be our left. Okay, so what we can do, we could actually do DFS over the tree, and we can print values in the list. Yeah, and then we take the median value and create a tree node from here. Then we do recursion here and recursion here. When we see here, we check if it's only one value, we just create new node and return. If it's two value, we create also new node, and here we can do everything. But what if we have something like this? So in this case, we can take, let's even create more. So here we have 7. So 7, it would be our root. Then we have left and right. We send into the recursion left, find 2, and send into the recursion 1 and 3. And return like 7, 2, 1, and 3. And here as well. Okay. So what we want to do. So first of all, we want to create our array and do DFS over root. Okay. Let's create this DFS. So we have our tree node. If root is equal null, we return empty array. Otherwise, we should what we should do, we should call DFS for root left and call DFS for root right. And here we will see, we will get left and right. And then we have our root value, so we can create our result array with left size, with left length plus right length plus 1, and we can put on the 0 root val and iterate equal to 1 less than left length. So let's have something like this. Okay. Okay, and here we put into our result left j, and here it would be right, and we return results. Okay, so for example, we have this one, yes. So we go left, and from left we return null, or we not return, we return empty array. Not 0, but it should be like empty array without any value. Then we go right. For 2 we go left empty array, then again go right, and when for 4 we return left and right empty, like here it would be 4. So we have our result, it would be 0, 0 plus 1. We put here 1 and return from the right one. When we on 3, yeah, we also would return 3. Okay, nice. So I think this DFS would work. So we have our array. Then, when we have our array implemented, we want to create this tree node. To create this tree node, we need this array. We need I and j, or let's call it left and right, like boundaries. And what else? What else? Yeah, probably that's it. We don't need root. And we can check like if. So what kind of options we can have? Let's consider. Imagine that we have only one, right? So we have boundary 1 and 0 and 1. So left would be 0, and right would be also 0. Yeah, it should point like to the value. So we can check if right minus left is less than let's go equal 0, and we return new tree node of array left. We have this, right? Yeah, we have constructor. Okay. What else we can have? I believe from the constraints that we have at least one, so at least one value. So it would be if we have such case. In this situation, we have 0 and 1. And we can check if right minus left equal 1. It means we have right and left, and we can return actually some node value and with left or right. So for here, it doesn't matter. For here, it doesn't matter. So we can return new tree node, let's say with array left and new tree node with array right. And now, yeah, so we have such two edge cases. Otherwise, we find our mid element from from both. So let's take another example. Let's say we have 1, 2, and 3. Here it will be 1 and 2. So we need to take mid value from these two boundaries. And yeah, so mid element, it would be right minus left divided by 2. Plus, I believe left to not have overflow. So we have mid index, and we can do like create new tree node with array mid, and this tree node would be our result. Then we call create with array here would be left, from left to mid, and this would be our left, and also we need right from mid to right, and then yeah, we can, I think we can do something like this. We return here just these two calls. Okay, and yeah, and that's it. Let's do some dry runs. So we have DFS, then we return create array from 0 to array length -1. So for example, we have this case. We go here, we calculate our mid. So mid would be right minus left. So it would be 2 minus 0, 2, plus 2, and plus 0. It would be 1. So we create our new tree node with 2, and send create with array. Left would be 0, and right would be mid. Yeah. 1 and 2. Here we can do like create array with mid plus 1 and right. Okay, so I think it should work something like this. So let's try to run it. Yeah. Okay. 2 and 3. No 4. 2. Yeah, it should be null. Yeah, let's consider this example. So we have 1, 2, 3, 4. Let's also print this array. Check. 1, 2, 3. Yeah. So here we have at the beginning 0 and 3. We calculate mid. So mid would be 3 minus 0 divided by 2. It would be 1. So we take 2 as our mid value. And we create 2 as a tree node. right? With array mid, and we should, if we create two, we should call with 0 with left and array mid -1. And here another one. Let's check. Two, one, three, null, null, 4. Okay. So my outputs 1, 2, 3, and 4. Expected. Output expected. Yeah, I'm wondering why it should be like this. Two, one, three, 1, 2, 3, 2, 1, 3. Okay. I have 2, 1, 3. So I take mid 0. 2, 1, 3. Okay. Yeah, so maybe when I do this DFS, I should take first left, then mid, and right. Okay. And what if I will put it here back? Okay, so let's run it and submit. Nice. So we have accepted solution, and let's check solutions here. Okay, so we are done, and thank you very much.